0. Now, there are a couple of questions happening. What is pH? What are acids? What are bases? What is it all about? Why pH of strongest acid is 0? That is our point of discussion. Has anyone thought about this? 0 means nothing in maths, isn't it? 0, nothing you represent by 0. And the strongest acid is having a pH 0. Isn't it counterintuitive? Why would strongest acid be 0? Why pH of strongest acid is 0? 0 in the conventional sense is nothing, 0, big 0. And how can the strongest acid be 0 in the scale, in any scale? This is confusing, isn't it? And alkali, strongest alkali is 14. If you look at the number scale usually is 0 in the middle and minus to one direction, plus to another direction, and that makes perfect sense. Neutral is 7. Why on earth 7 becomes neutral? Why can't it be 0? Anyone thought about this? There is a problem. There is something abnormal with this. This is why I thought I will explore a little bit more into this question, why pH of strong acid is 0. Okay, when we are going into acids, for those who wondering what can acid do, here is a very acidic, very corrosive substance called Piranha solution. Piranha solution is a mixture of sulfuric acid and hydrogen peroxide, and it can eat away flesh. And here in this video you can see how the chicken drumstick is being attacked by the Piranha solution. He is adding more and more peroxide into that, and you can see including the bone is disappeared. That is how powerful this acid is. You may be thinking, oh, is this only for meat? It can dissolve metals, and one of the most inert metal or precious metal is gold. Some of these acids, not all acids can dissolve gold, but there is a mixture of acids which can dissolve gold. Even gold dissolves in it. Have a look.
What I have here is 100 grams of pure gold. At around $57 US per gram, I think I'm just going to destroy it using acid. All I have to do is pour in a bunch of concentrated hydrochloric acid, and I'll bring this to a boil.
Hydrochloric acid alone cannot dissolve gold. You can see he's
right now, not much is happening, and I have to add some nitric acid.
Okay, the mixture of hydrochloric acid
immediately,
and nitric acid.
The gold starts getting torn apart. I then kept occasionally adding acid, and over the next few hours, it slowly disintegrated.
Yes, look at
then
that.
Eventually,
bright
it completely disappeared.
Solution.
What I was left with was a nice red liquid, which turned orange after it cooled down. There was also no trace of the gold bar, and it's almost like it never existed.
Even gold can be dissolved using certain acids. If not one acid, you need 2 acids. Okay, this is what you are going to learn from today's live streaming. The amazing world of acids and bases, understanding pH, what is pH, defining strength of an acid, mathematics of pH, why pH of strong acid is 0. We will be answering that question towards the end. And there comes another question. Is there anything beyond 0? Can there be even more powerful acids than pH 0. Always we want to go one step ahead or one step beyond to know what is happening. So at the end we will address that question, even stronger than 0 pH. Okay. Now in the ancient time, people used to classify material as sour, like lime, vinegar, and all. They have the sour taste, and you have bitter tasting materials or substances like bitter gourd, soap. If you have never tasted bitter gourd or soap, just go ahead and taste that taste, bitter taste. I'm sure most of you would have tasted lime. And it is not practical going around and tasting everything. Yeah, this is sour, therefore it is acid. This is bitter, therefore it is base. And so people try to find an instrumental method to identify acids and bases, and this is what we call indicator. Something, any material that can indicate the presence of acid or base is called an indicator. As you have seen, a drop of that solution turned the whole solution into pink, and that indicates the pH, the nature of that solution. Okay, how did it all start? Okay, let's look into the origin of these indicators. You might have seen this algae and fungus together called lichens. You would have seen this on trees or somewhere, and if you look into the details, if you look more and more pictures, you will see so many different colors for this organism called lichens. And ancient people identified they can be used to indicate what is an acid or a base, and they extracted the chemical causing this color change. They identified certain specific organisms from lichen family which can indicate. This word litmus comes from lichens. Okay, litmus can turn into blue or red depending upon acidity or alkalinity. In bases, it becomes blue. In acids, it becomes red. So this is two drastically different colorations, and from there you can identify. As you can see from the picture, lemon is showing red, ammonia, which is a base, showing blue. Similarly, people also discovered vegetables like red cabbage can indicate colors. Here is a small video. I will play it.
Hey guys, welcome back to my booth. Today we are going to do some cool science experiments using some red cabbage. I know it's purple, but it's...
Anybody can do this. You can just get a red cabbage, put it in a blender, blend it, filter it, or even you can boil it in hot water. Boil it and get the juice, filter the juice, and you can use it as an indicator. You can use red cabbage juice as an indicator. So here he has put lime juice, lemon juice, vinegar, carbonated soda, water, toothpaste, and drain cleaner, etc.
Water, toothpaste and water solution, baking soda and water solution, and finally bleach. Now I'm going to pour my indicator into the glasses to see what happens. The lemon juice, being the most acidic of the lot, changes to a bright red color. The vinegar changes to a pink or a less bright red color. The lemon soda changes to pink shade. The water, being neutral, takes the color of the indicator and becomes purple. The toothpaste and water solution changes to a blue shade, which means now we have stepped over to the alkaline zone. The baking soda and water solution turns a bluish-green shade. And finally, the bleach, being the strongest base of the lot, dissolves the purple color completely and retains its own light yellow color. You can see how the indicator has changed color in all the different solutions. This is a very fun and easy experiment you can try at home for almost free, and it is also an excellent and safe way to demonstrate the concept of acids and bases to kids.
Okay, I always show this experiment to children, and if parents can help children do this in home, they will never forget the idea of acids and bases, the indicators, etc. In many schools, teachers try to do it. If parents can help children do this, it will be a good idea. Very simple, inexpensive kitchen experiment. Okay, so in pH scale, we can classify materials into different pH, like battery acid, it's almost zero, sulfuric acid is there. And you have stomach acid. Stomach acid is hydrochloric acid, which has got a pH of 1, lemon 2, vinegar 3, tomato 4, coffee 5, and milk is slightly acidic with a pH 6. Pure water, in all practical purposes, water will not be pH 7, but pure water is supposed to be neutral and 7. And blood is slightly alkaline with a pH 8, baking soda 9, stomach tablets, if you have indigestion, you will be taking something like Gaviscon. Gaviscon will have some pH 10, ammonia solution 11, soap 12, bleach 13, and drain block remover, very powerful. Drain block remover typically contains 10 to 11% of sodium hydroxide, a powerful alkali. It's not even 100%, it's just 10 to 15%. It varies depending upon the brand, and it is very dangerous as well. Okay, so here is some of the day-to-day materials organized, arranged in the pH scale, or looking through the pH lens. This is the pH of day-to-day substances. By the way, where are we getting these numbers from? That is a question, isn't it? Where are we getting these numbers from? pH scale, and this is an abnormal scale. pH scale is not usual in the sense that strongest acid is given 0, nothing in that scale. This is the very question we were asking. Why acid is given 0 pH and the strongest base is given 14? Shouldn't it be minus 14 acid? Why is it given 0? This is the burning question we are trying to answer. So coming back to the pH scale, 7 is the middle in this stupid scale. 7 is the middle, and 0 is the acidic extreme. 14 is the basic or alkaline extreme. Alkaline and basic, there is a subtle difference. Any basic substance that dissolves in water is called alkali. If a basic substance do not dissolve in water, that can only be called base, cannot be called alkali. And most of the alkalis are more powerful, like sodium hydroxide, potassium hydroxide, cesium hydroxide, and all. Very, very powerful alkalis. They dissolve first group elements, hydroxides of first group elements dissolve in water. Okay. Now, pH scale. We want to discuss the mathematics of pH scale. Okay. Logarithm. So we will discuss a couple of these ideas. pH is defined as, okay, I should be writing strictly, I should be writing P of potency of hydrogen. pH is negative log hydrogen ion concentration. It is the concentration of hydrogen ions taken to the logarithmic scale. This is the mathematical expression of pH scale. So negative logarithm of hydrogen ion concentration. In chemistry, if we put the square brackets, that indicates concentration of anything. If you put H plus inside, hydrogen ion concentration. And this is the next one is logarithm. Here we are missing something. Definitions of acids and bases. Acids are defined as H plus ion donors. This is the definition by great Arrhenius. H plus ion donors, and bases OH minus ion donors. That means when this is it dissociates to give H plus ions, and bases give OH minus ions. And you can see this H plus ion is appearing in this equation. How much H plus ions are there, and the concentration, you can see concentration of H plus ion is linked with pH scale. We'll explain the two concepts you need to understand to better appreciate the pH. Okay, going to the next page. What are logarithms? Logarithms are the opposite of exponents. Say for example, you write 2 to the power of 2 is 4. And if I want to know what power of 2 is 4, I have to ask log 4 to the base 2. What is it? You should get this power. That is what you have, 2. And by the way, in the theory of exponents, this is called base. And this is called exponent or power. This is base. Okay, this is the base you are seeing here. That is the base. So what power of, can you see 4 and 4 there? What power of 2 is 4? Second power. Second power of 2 is 4. Now similarly, if I write 2 to the power of 3 is 8, you can ask the reverse question, log 8 to the base 2. The meaning is what power of 2 is 8? That is third power. 2 to the power of 4 is 16. So you can ask the reverse, log 16 to the power of 2 is 4. I hope you understand the idea. You can find this in calculators. Here is a scientific calculator, and you should be able to see a button called log. Can you see this? In scientific calculators, there is a button like log. Can you see? Log button. All you have to do is press log 16. You can try now. Log 32. You should get log 32 should be 5. Log 64 should be 6. This means 2 to the power of 5 you will get 32. 2 to the power of 6 you will get 64. By the way, I should have written 2 there. Yeah. So this is the idea of logarithm. Logarithm gives you the power. Okay. Now you can practice in your calculator log 100. Oh, this logarithm was based on 2. Now you can find logarithm to the base 10. You know this. 10 to the power of 1 is 10. 10 to the power of 2 is 100. 10 to the power of 3 is 1000. Now if you punch in the calculator log 10, you will get 1. Log 100, you will get 2. Log 1000, you will get 3. Okay. So this gives the power of 10. This means 10 to the power of 1. 10 to the power of 1 is 10. This means 10 to the power of 2 is 100. Okay. This means 10 to the power of 3 is 1000. You can see this. So if you take logarithms, you will get this power. Which power of that base is the number? Extending this to the fractions, log 1 by 10. Can you guess what you get? Log 1 by 10. Log 1 by 100. Can you guess what you get? For log 10, you get minus 1 because this is log 10 to the power of minus 1, which is minus 1. Log 1 by 100 is 10 to the power of minus 2. Therefore, this will be minus 2. You can practice this using different numbers, log 1 by 100, log 1 by 1000, different numbers. That will give you a fair idea of how the fractions work. Okay. Let's move on to the idea of concentration. Concentration means amount of a substance in a given volume. Concentration can be expressed in two ways. That is, amount of substance divided by the volume. And amount of substance you can express as gram per liter or mole per liter. Okay, both are right. You can use either of the ways, gram per liter or mole per liter. And it so happens concentration, if you have 1 mole per 100 milliliter or whatever, so it becomes a fraction. Can you see? 1 out of 100. It will be 1 out of 1000 or 1 out of 10, something like this. And the beauty of pH appears from combining the idea of concentration with the pH. Now try to see this. Concentration of acid, like H plus ion concentration. Imagine if the acid produces 1 H plus ion, acid 1, if an acid 1 produces 1 H plus ion out of every 10 molecules, the concentration of H plus ion is 1 by 10. An acid 2, if it produces 1 out of 100, it's not as concentrated as that one, first one, acid 1. Acid 2 has got hydrogen ion concentration, H plus ion concentration of 1 by 100. So depending upon this, you can calculate, depending upon the hydrogen ion concentration given by each acid, we can identify the concentration. You can convert this into the pH scale. Okay, and again, coming back to pH scale, pH is defined as negative logarithm to the hydrogen ion concentration. This is the mathematical definition of hydrogen ion concentration. Now let's combine these two. pH, H plus ion concentration, logarithm, and pH. pH is equal to, okay, I should be writing small p, pH is equal to -1 times log H plus ion. Okay, let's log H plus here. So here I am creating a small table. hydrogen ion concentration. Imagine we have 1/10. Imagine we have a concentration. Imagine we have a concentration of 1/10, 1 out of 10. What would be the log hydrogen ion concentration? Check using your calculator. What would be the hydrogen ion concentration? Check using your calculator. So you have to put log in bracket 1/10. You will get -1. And to convert this -1 to pH, you have to multiply again using -1. So this becomes pH is equal to -1 times -1. There you go. You are getting a pH of 1. Can you see? 1/10 concentration is called pH 1. If you have a concentration of hydrogen ion 1 out of every 100 molecules, the log hydrogen ion concentration is going to be log 1/100, which is going to be -2. Now -1 times -2, you will get 2. That means 1/100th concentration is pH 2. If you convert this into percentage scale, you know this is 1/10 is 10%. 1/100 is 1%. Can you see? 10% is pH 1, 1% is pH 2. The relationship is twisted because you are multiplying this with a -1. And again, this is a logarithmic scale. It is the power of 10. Okay, if you go to 0.1% strength, that is 1 H plus ion concentration in every 1000 molecules, the log will be -3 and pH is going to be -1 times -3 is equal to 3. And you can extrapolate this, like, you know, if it is 1/10,000, number of, this is -4, log hydrogen ion concentration is going to be -4, and this is -1 times -4 is equal to 4. And you can go on and on like this, and the takeaway should be, you know, lower the concentration, higher the pH number. And I think we are ready for going into the pH 0. Let's reverse calculate. When this is 0, when can this be 0? When the log H plus ion concentration is 0, right? Then -1 times 0 becomes 0. And hydrogen ion concentration is going to be 1/1. That means this is 100%, 1 out of 1. It is 100% concentration, 1 out of 1. You know this. 10 to the power of 0 is 1. And that 0 is appearing here. And that 0 is appearing here. And 0. And 100% solution, you can see, is pH 0. I hope you understand the mechanism, how you are getting this. The mathematics logarithmic scale 10 to the power of 0 is 1. That is the reason why you get this 0 here. 100% acid. Every molecule of acid, every acid molecule produces a hydrogen ion. Or in other words, 10 to the power of 0 is 1. Okay, you can see as the concentration goes down, the pH increases 0, 1, 2, 3, 4.